Precalculus 1.6 inverse functions. What you should learn in this lesson is how to find inverse functions informally and verify that two functions are inverse of each other. Use graphs to decide if two functions are inverses. Determine whether the function is 1 and 1, and then find inverse functions algebraically. So an inverse function is just a function where you switch the inputs and the outputs. So we're going to switch the x values with the y values. That's in a nutshell. That's what inverse function is. It switches the inputs and the outputs, or switches domain and range. Right? That's it. So how does that work in a function? So if you see here, they give you an example of like, here's a function, then here's its inverse. And we'll talk more about why that's its inverse. But if you notice, all my x, y points and the inverse switch. So it goes from 1, 5 to 5, 1, 2, 6 to 6, 2, yada yada. So that's what, at the bare minimum, that's what an inverse does. It switches the domain and range, switches the x and the y. So our first example here, let's find the inverse of this function informally. So if I want to find the inverse of this function, all we're going to do is switch our x's and our y's. We're just going to swap them. So it becomes -8, -2, -7, -1, -6, 0, -5, 1, -4, 2. And that's the inverse. You just switch x and y. Next, how can I tell if two functions are inverses of each other? So we kind of talked about this last video, but when you do a composition of functions and they cancel each other out and you just get x for every value, those two things are inverse of each other. So very important result if you do a composition of functions, right? G of x, and you get x, and it happens the same way when we do the opposite way around, then those two things are inverses of each other. So that's how you can tell if two things are inverses of each other. So if this happens, you're like, oh, then that means that these are inverses. So you could say g of x equals the inverse of f. And I'm just letting you know, like, that's what the inverse notation is. F with the -1 power, or g with the -1 power. That thing means inverse. So that's the inverse of f of x. So let's try it. So we want to show that these two things are inverse to each other. So if I see that, I'm like, okay, we're going to do f of g of x. So we're going to let's plug g into f. So what is f? F in this case is 2 times something cubed minus 1. That's what f is. And we're going to plug g into it. So we're going to plug this mass into there. It looks disgusting, but usually with inverses, it works out really nicely. So let's see. Let me change my color there. So what happens here is the cube and the cube root cancel out, and we're left with 2 times x plus 1 over 2 minus 1. And then what happens, the 2's cancel out, and you're left with x plus 1 minus 1, and then the 1's cancel out. You just get x. So they're inverses. Technically, you're supposed to try the other way around also. So I should plug this into there. But if it works one way, it works both ways. But technically, you're supposed to do this. I'm not sure if I've ever seen it where it only works one way. If it works one way, it's going to work the other way. So you have this, and you're like, oh, that looks ugly also. But again, not too bad, because look at the 1's cancel out first. And you get the cube root of 2x cubed over 2, and then the 2's cancel out. And you're left with the cube root of x cubed. So those cancel out, and you just get x. So that's how you can tell if two things are inverses. You do the composition of functions, and they cancel each other out, and you get x. They're inverses. So example 4, which of these functions is an inverse function of this? So you would just do composition of functions with these. I guess I'll do a real quick to show you what it looks like when it's not inverse. So like this, let's try the first one. Right? Let's go this one with this one. We're going to do f of g of x. So we're going to plug g into f. Again, it doesn't matter which way you do it. You have to cancel out. So in this case, I'm just do f of g. So f is this guy. Then let's plug in g. So x minus 2 over 5. I can tell you right now, this is not the inverse. If you look at it, right, like, nothing's going to cancel out. Like, I have to do common denominator. It gets disgusting. So those are, I don't think that's, so that's pretty sure not the inverse. Let's do the other one. Let's do f of h of x. So same idea. Again, I could switch it if I want. I could do like h f of h of x, or h of f of x, I should say, but I'm just going to keep it the same just so we can see it. Right, so that's my f, and then we're going to plug h in. H is this guy. So 5 over x plus 2. Now look at this one, right? So this one, I was like, oh my god. This one looks scary at first, but look what happens. These cancel out, and then you're left with 5 over x. That looks a little scary, but don't freak out. Just rewrite it. This is a divide sign. This is saying 5 divided by 5 over x. Remember the way you divide fractions? Multiply by the reciprocal. So 5 times x over 5. These cancel, you just get x. So that's the inverse. So again, when they're inverses, it should work out kind of nicely. You shouldn't have to do a bunch of math. It should be kind of like, it should be smooth. Okay, what about the graph of the inverse function? So remember, what an inverse actually does, right? It switches x and y. So if you see this little dotted line right here, this line, that's y equals x. So if you're switching x and y, if you just switch the points, you should kind of go across that line. Easiest way to find the inverse is literally just get a point AB and then switch it to BA. Alright, so like switch the x and y values. So if you want to graph an inverse, the easiest way to do it is just get the points and then flip them. And when you graph it, what's going to happen is it's going to flip across this y equals x line. So it's going to flip perfectly across there. So that's how you can tell when something's an inverse. It should flip perfectly across an xy line. If the next thing is, how do you tell if something is how can you tell by looking at it if it's an inverse function? So that's what this is about. How to tell if a function has an inverse. Has an inverse function. Like every function has an inverse, but is it an inverse function? Is it like, does it pass the vertical line test like that? So what we do is we have something called one-to-one function. A one-to-one function has an inverse function. So if it's a one-to-one function, it's going to have an inverse. If it's not a one-to-one function, its inverse won't be a function. So we have these things called a one-to-one function. And how do you tell something's one-to-one? You have something that's called horizontal line test. So this is a horizontal line test. It works just like the vertical line test, but the horizontal line test tells you if it passes, then it's a one-to-one function, which just means it's inverse. It has an inverse function. Has inverse function. So I know it's a lot of math jargon, but if I ask you, hey, is this function, like look at this function here, like does that have an inverse? You could do the horizontal line test and like, oh, this does not, right? This fails. Remember, when you do a horizontal vertical line test, it can only cross once. So like, oh, this fails. So it does not have an inverse function. So y equals x squared would not have an inverse function. Compare that to something like x cubed. It looks like this. Right? If I did a horizontal line test there, I only ever hit at one spot. So this does have an inverse. Right? So x squared is a good example. This is a function. It passes the vertical line test, but it does not have an inverse. X cubed, it's a function, passes the vertical line test, but it also passes the horizontal line test. So it has an inverse. That's what's going on there. Little note here, if f is an increasing on its entire domain, so that just means it's going up the whole way. So kind of like x cubed. So if it keeps on going up, then it's going to be one-to-one. Same thing if it's decreasing the whole way. So it's just constantly going down. If those two things are happening, if one of those happens, it's a one-to-one function. So it means it has an inverse. So that's a little note, not a big deal. Okay, last thing we're going to do for this lesson, probably the most important part. How do we find the inverse of a function algebraically? So it has a little rules here. I'm just going to go through it. I'm going to make it a little easier here. So step one. So it's steps. Step one, switch. Actually, not switch. Switch is a bad word for that. replace f of x with y. It's probably better if I write the whole word down. So remember, f of x and y are the same thing. It's a lot easier to work with the y than it is f of x. So we're sort of first thing to do, if I'm like, hey, find the inverse of this guy. Step 1, we're going to change f of x with the y. 2, inverse step. What does the inverse do? Inverse is you want to switch x and y. So we're really going to switch x and y. So I'll switch this x with the y, and I'll switch the y with an x. 3, solve for y. So that's we do that. We're going to solve for y, try to get y by itself. And then 4, replace y with f inverse of x. Right, so we want to name it properly. So we do all the math. So step 1, right? To make it work better, we're going to change f of x with the y. Then we're going to switch x and y. We're going to solve for y, and then we're just going to go, okay, this is our inverse, so plug it in there. Then step 5 is check your work. So you can do the f of g of x to check your work. So those are the big 4 steps. So let's do a few examples, and then we're done. So we want to find the inverse function of this guy. So step 1, we'll make this a y. So it's something like this. Y equals 5 minus 3x over 2. Next step, we're going to switch the x and the y. So we're going to switch those two. So that's going to be an x equals 5 minus 3y over 2. Next, we want to get the y by itself. So I'm going to get rid of the 2 first. Let's multiply everything by 2. So we get 2x equals 5 minus 3y. Then we just got to solve for y. So let's subtract 5 from both sides. So this is 2x minus 5 equals negative 3y. Then we're going to divide by negative 3. Right, we're trying to get the y by itself here. Divide all by negative 3. So I get this. Y equals 2x minus 5 over negative 3. And normally you're done, but don't forget, that's my inverse, so we got to replace this and write it as an inverse. So f to the negative 1 of x equals 2x minus 5 over negative 3. And if you want, you can check your work. Like, did I do this correctly? Remember, all we have to do is plug one into the other. It doesn't matter which one into which. I could plug this into there. If you want to do it, you can do it up. I'm going to do it up here to show you. So you can do, like, I'm going to check my work. So 5 minus 3 times something, which is 2x minus 5 over negative 3, all over 2. Right, I'm going to plug this into that guy real quick. Look what happens. Negative 3 and negative 3 cancel out, so you're left with 5 plus 2x minus 5 over 2. Then look what happens. 5's cancel out, 2x over 2, 2's cancel, you just get x. So I did it correctly. Right, that's the process of finding the inverse algebraically. First, if it has an f of x, make it a y, and then you switch x and y, like I did here, right? So now switch x and y. Then you just try to get y by itself, so do the math to get y by itself. Once you do that, rewrite y as an inverse, and then you're done. If you want, you can check your work. Right, plug one into the other. Last one here, just to check. Okay, so same process. First, I'm going to make this a y. Y equals x cubed minus 4. Step 2, we're going to switch x and y. So x goes here, y goes there. Here's the reason I want to do this problem. So I want to show you that. Where does the 3 go? Does the 3 go with the x, or does it go stay with the y? Like, does it go? Does it follow the x around, or does it stay here? It stays. Right, so the only thing you switch is literally the letters. So x and y get switched, everything else stays the same. And now you solve for y. So we're going to add 4 to both sides. X plus 4 equals y cubed. Take the cube root. And we get y is equal to the cube root of x plus 4. Finally, I'm going to switch this with f inverse. And we're done. That's how you find the inverse algebraically.